Look at your arm right now. Look at the skin, the tiny hairs, the smoothness. Now imagine a chimpanzee's arm, covered in thick, dark fur, dense, protective. That's what you should look like. That's what our ancestors looked like. Because we're primates, great apes, members of the same family as chimps, gorillas, orangutans, and every single one of them is covered in fur. Thick coats of hair protecting their skin. Except us. Humans are naked, almost completely hairless. We have about 5 million hair follicles on our bodies, the same number as a chimpanzee. But our hair is different, thin, short, barely visible. We call it vellus hair, peach fuzz. It doesn't protect us from the sun, doesn't keep us warm in the cold, doesn't shield us from insects or thorns. We're naked apes, vulnerable, exposed, and we have no idea why evolution did this to us. Scientists have theories, lots of theories, about water, heat, parasites, sex. But we can't fully explain why humans lost their fur, why we became the only hairless primate on Earth. It happened around 2 million years ago, somewhere in Africa. Our ancestors, Homo erectus or their predecessors, began to lose their body hair. And by the time modern humans emerged 300,000 years ago, we were completely hairless. This is one of the most distinctive human traits, right up there with walking upright and having big brains, and it's a mystery, a puzzle that scientists are still trying to solve. If you're using this to fall asleep, perfect. Let this mystery wash over you as you drift off. And if you're still awake in a couple minutes, I'll ask you to subscribe, because this channel explores mysteries like this. Things we can't explain. Things that make us uniquely human. Drop a comment and let me know where you're watching from, what time it is, and whether you think humans look weird compared to other apes. I love reading these, because our hairlessness is so obvious once you notice it. But most people never think about it. Let's start with the basics. How hairy are we, really? Humans have approximately 5 million hair follicles on our bodies. That's about the same as a chimpanzee. So we're not actually hairless, we have the same number of follicles, but the hair that grows from those follicles is completely different. Chimp hair is terminal hair, thick, pigmented, long. It forms a dense coat that covers almost their entire body. Human hair is mostly vellus hair, thin, light-colored, short, barely visible. We do have some terminal hair on our heads, in our armpits, in our pubic regions, on our faces for men. But the vast majority of our body is covered in vellus hair, which provides almost no protection. This is strange, because hair serves important functions: protection from the sun, protection from cold, protection from insects and abrasions. Every other mammal has fur. Even marine mammals like seals and otters have dense coats. The only truly hairless mammals are a few specialized species: naked mole rats, elephants, rhinos, whales. And these species have specific adaptations that explain their hairlessness. They live underground. Or they're so large that overheating is a problem. Or they're fully aquatic. But humans? We don't fit any of these categories. We live on land. We're medium-sized. We're exposed to the elements. We should have fur, but we don't. Now, before we go deeper, if you're enjoying this exploration, hit that subscribe button. This is We Can't Explain, and we dive deep into evolution's greatest mysteries. Things like why we have white eyes, why we experience the Toba catastrophe, why red hair is disappearing, all the things that make being human strange and wonderful and inexplicable. New mysteries every week. Subscribe so you don't miss them. Okay, Back to our missing fur. Let's talk about when this happened, because timing is important. Our earliest ancestors, the ones who split from the chimpanzee lineage about 6 to 7 million years ago, were probably still hairy. They would have looked like other apes, covered in fur, living in forests, but somewhere around 2 to 3 million years ago, something changed. Our ancestors began to lose their fur, and their skin began to darken. We know this from indirect evidence. We can't fossilize hair, but we can look at modern humans and trace back when the changes must have occurred. Dark skin pigmentation, melanin, protects against UV radiation. You only need dark skin if you're exposed to the sun. If you're covered in fur, your skin can be light. The fur protects it. But if you lose your fur, you need dark skin. Otherwise, you'd get severe sunburn, skin cancer, DNA damage. So, the evolution of dark skin tells us when humans lost their fur, because the two would have happened together. Genetic studies suggest that the genes for dark skin became universal in African populations around 1.2 million years ago. This implies that humans were already hairless by then, at least the populations living in sunny Africa. So hairlessness evolved sometime between 2 million and 1.2 million years ago, during the time of Homo erectus, or their immediate predecessors. This was a crucial period in human evolution. Our brains were growing. We were developing tools, learning to control fire, becoming more sophisticated, and we were losing our fur. Let's explore the main theories, because scientists have proposed many explanations for why this happened. Theory 1. The aquatic ape hypothesis. This is the most controversial theory, and it's probably wrong, but it's interesting, so let's discuss it. The idea is that humans went through an aquatic or semi-aquatic phase, that we spent significant time in water, wading, swimming, diving for food, and this aquatic lifestyle led to the loss of body hair. Just like other semi-aquatic mammals, seals, whales, dolphins have reduced fur. Proponents point to other features that might support this. Our subcutaneous fat layer, our ability to hold our breath, our descended larynx, but most scientists reject this hypothesis. The evidence is weak. The alternative explanations for these features are more convincing. And there's no fossil evidence of a semi-aquatic human ancestor. No evidence that our ancestors lived near water more than other primates. So while the aquatic ape hypothesis is fun to think about, it's probably not the answer. Theory 2. Thermoregulation. The cooling hypothesis. This is the most popular and widely accepted theory. The idea is that humans lost their fur to stay cool, to prevent overheating during physical activity in hot environments. Here's the reasoning. Around 2 million years ago, our ancestors moved from forests to open savannas. They began hunting, chasing game across long distances. This is called persistence hunting. Humans can run for hours in the heat of the day. We can chase an antelope until it collapses from exhaustion. But this requires exceptional cooling, because running generates a lot of heat. And if you can't cool down, you overheat, you collapse, you die. Other mammals cool primarily through panting. Dogs pant, cats pant, antelopes pant, but panting has limits. You can't run and pant effectively at the same time. Humans cool through sweating. We have 2 to 4 million sweat glands on our bodies, more than any other primate, and sweating is incredibly efficient. When sweat evaporates from your skin, it takes heat with it. It cools you down. But sweating only works if your skin is exposed. If you're covered in fur, sweat gets trapped. It can't evaporate. It just makes you wet and uncomfortable. So the theory is, humans lost their fur to maximize the effectiveness of sweating, to enable persistence hunting, to stay cool while running in the African heat. This makes sense. It explains why hairlessness evolved in Africa, in hot, open environments where cooling was critical. And it explains why humans are such exceptional endurance runners. We can outlast almost any mammal in a long-distance chase. But this theory has problems too. First, other animals hunt in the heat without losing their fur. Lions, hyenas, wild dogs. They manage. Second, human infants and children are also hairless, but they don't persistence hunt. So why are they naked too? Third, hairlessness exposes us to the sun, which creates the risk of sunburn and skin cancer. Did the cooling benefits really outweigh these costs? The theory is compelling, but it's not conclusive. Theory 3. Parasite avoidance. This theory suggests that humans lost their fur to reduce parasites. Lice, ticks, fleas, mites. Fur is a great habitat for parasites. They live in it, breed in it, feed on the host's blood. Parasites cause disease. They transmit pathogens, bacteria, viruses, protozoa. If you're covered in fur, you're vulnerable to these parasites and the diseases they carry. But if you lose your fur, parasites have nowhere to hide. They can't establish populations on smooth skin. So the theory is, humans lost their fur as a defense against parasites, as a way to reduce disease and improve health. This makes sense, especially in social species, where parasites can spread quickly through a group, and it explains why we kept hair in certain places. Our heads, our armpits, our pubic regions. These are areas where hair might still be beneficial. Head hair protects against sun and heat loss. Armpit and pubic hair might play a role in sexual signaling or pheromone dispersal. But if the main goal was parasite avoidance, why keep any hair at all? Why not be completely bald? And other primates deal with parasites through grooming. They pick lice out of each other's fur, social bonding through grooming. Humans could have done the same. Why resort to losing all the fur? The parasite avoidance theory is plausible, but not fully convincing. Theory 4. Sexual selection. This theory suggests that hairlessness became sexually attractive, and that's why it spread. Sexual selection is powerful. Traits that are considered attractive get passed on, even if they have no survival advantage. Maybe early humans found smooth skin attractive. Maybe it signaled youth, health, cleanliness, and individuals with less body hair had more mating opportunities, so hairlessness spread through the population. This would explain why humans are uniformly hairless. If it's a sexually selected trait, everyone would have it. And it would explain regional variations in body hair. Different populations have slightly different amounts of body hair, maybe due to different aesthetic preferences, but sexual selection usually creates dimorphism, differences between males and females. Male peacocks have elaborate tails. Female peacocks don't. Male lions have manes. Female lions don't. But human hairlessness is the same in both sexes. Both men and women are mostly hairless, so sexual selection alone probably isn't the answer. Sleep well. Dream of smooth skin and ancient savannas, of ancestors running under the hot sun. Good night. Theory 5. A combination. The multi-factor hypothesis. Most scientists now think that hairlessness wasn't caused by one factor, but by multiple factors working together. Maybe our ancestors moved to open savannas. This created cooling pressure. Sweating became more important, and at the same time they were social, living in groups. This made parasite transmission easier. So reducing fur provided health benefits, and maybe on top of this, smooth skin became aesthetically preferred. Sexual selection reinforced the trend. All of these factors together pushed humans toward hairlessness, and once the trend started, it was hard to reverse. This multi-factor hypothesis is probably closest to the truth. Evolution rarely has single causes. It's usually a combination of pressures and benefits, but we still can't prove it. We can't go back 2 million years and observe what was happening. We can only theorize, make educated guesses based on anatomy, behavior, and comparative biology. Now let's talk about the hair we kept. Because humans aren't completely hairless, we have hair in specific places. Head hair is the most obvious, long, thick hair on our scalps, unlike any other primate. Why did we keep this? Several reasons. First, protection. The head is exposed to sun. Head hair provides shade, reduces heat absorption, protects against UV radiation. Second, insulation. The brain is sensitive to temperature. Head hair helps maintain a stable temperature. Third, possibly sexual signaling. Long, healthy hair might signal youth, health, fertility. But here's something strange. Human head hair grows continuously, unlike body hair, which stops at a certain length. If you never cut your head hair, it would grow several feet long. This is unusual. Most primates have hair that stops growing at a fixed length. Why do humans have continuously growing head hair? We don't know. It might be a byproduct of the genes that control hair growth, or it might serve some unknown function. We also kept armpit hair and pubic hair. This is called androgenic hair. It develops during puberty. Why? Several theories. One idea is pheromone dispersal. Armpits and pubic regions have apocrine sweat glands. These glands produce oily sweat that contains pheromones. Hair in these regions might help trap and disperse these pheromones, making them more detectable. This would be useful for sexual signaling, attracting mates, communicating reproductive status. Another idea is friction reduction. Hair in these areas might reduce chafing during movement, especially in the groin area during walking or running. Or maybe it's just a vestige, a remnant of our furry past that hasn't been selected against. Men also develop facial hair, beards, mustaches, sideburns. This is clearly sexually dimorphic. Men have it, women don't. So it's likely a sexually selected trait. Women might find beards attractive, or beards might signal dominance to other men. Beards are highly variable across populations. Some populations have thick, dense beards. Others have sparse facial hair. This suggests that different populations experience different selection pressures or different aesthetic preferences. Let's talk about the evolutionary timeline in more detail, because hairlessness didn't happen overnight. Around 6 to 7 million years ago, the human lineage split from the chimpanzee lineage. At this point, our ancestors were probably still fully furred. Around 4 million years ago, Australopithecus emerged. These were early hominins, walking upright, but still living in forests and woodlands, probably still furred. Around 2 million years ago, Homo erectus appeared. This is when things get interesting. Homo erectus had a larger brain, better tools. And they left Africa, migrating to Asia and Europe. They also were probably the first hairless humans, or at least significantly less hairy than their predecessors. How do we know? Several lines of evidence. First, body proportions. Homo erectus had long legs and narrow hips. This is a body shape adapted for running in open environments, for dissipating heat. You don't need this body shape if you're living in forests. You need it if you're hunting on savannas in the heat. Second, brain size. Homo erectus brains were significantly larger than earlier hominins. Brains generate a lot of heat. You need effective cooling if you have a big brain. Hairlessness and sweating would help with this. Third, fossil locations. Homo erectus fossils are found in open savanna environments, not dense forests. This suggests they were adapted to hot, sunny conditions, and in those conditions, hairlessness would be beneficial. By the time Homo sapiens emerged 300,000 years ago, we were fully hairless. This is clear from our anatomy and physiology. We have dark skin in tropical populations. We have millions of sweat glands. We have body shapes optimized for heat dissipation. All of this points to hairlessness being a very old trait, something that evolved early in the Homo lineage. Now let's discuss skin color, because hairlessness and skin pigmentation are closely linked. When humans lost their fur, their skin was exposed to the sun. Direct UV radiation. UV radiation is dangerous. It damages DNA, causes mutations, leads to skin cancer. To protect against this, humans evolved dark skin. High levels of melanin. This pigment absorbs UV radiation and prevents it from penetrating deeper layers of skin. In Africa, where UV radiation is intense year-round, dark skin is universal. It's a necessity. But when humans migrated out of Africa into higher latitudes, the UV pressure decreased, and a new pressure emerged. Vitamin D synthesis. Vitamin D is produced in the skin when it's exposed to UV radiation. You need vitamin D for bone health, for immune function. In low UV environments, like Northern Europe, dark skin blocks too much UV. Vitamin D synthesis drops. People develop deficiencies, rickets, weak bones. So in these populations, lighter skin evolved, less melanin, more UV penetration, better vitamin D synthesis. This explains the range of human skin colors. Dark skin in the tropics, light skin at high latitudes, medium skin tones in between. It's a balance. Enough melanin to protect against UV damage, but not so much that vitamin D synthesis is impaired. And all of this only matters because we're hairless. If we still had fur, skin color wouldn't matter. The fur would protect us. Let's talk about modern humans and body hair, because there's variation. Some populations are hairier than others. Mediterranean populations, Middle Eastern populations, South Asian populations. They tend to have more body hair. East Asian populations tend to have less. Indigenous American populations even less. Northern European populations are somewhere in the middle. Why the variation? We don't know for sure. It might be sexual selection, different aesthetic preferences in different regions. It might be environmental. Colder climates might favor slightly more body hair for insulation. Or it might be genetic drift, random changes that accumulated over time. What's clear is that even the hairiest human populations are still mostly hairless compared to other primates. The variation is minor, a matter of degree, not a fundamental difference. Let's talk about the cultural response to hairlessness, because humans have always been aware of it. In almost every culture, humans cover their bodies. We wear clothes. This seems obvious, but it's not. Other primates don't wear clothes. They don't need to. They have fur. But humans need clothes for warmth, for protection, for modesty. Clothing is a cultural adaptation to our biological hairlessness. We lost our natural covering, so we created an artificial one. The earliest evidence of clothing is indirect. Sewing needles appear in the archaeological record around 40,000 years ago. But humans probably wore simpler clothing, animal skins, plant fibers, long before that. Genetic studies of human lice suggest that clothing lice, parasites that live in clothing, diverged from head lice around 170,000 years ago. This implies that humans were wearing clothes by then, at least sometimes, so clothing is ancient, almost as old as modern humans, and it's universal. Every human culture wears some form of clothing. Even in hot climates, people wear something. This shows how vulnerable hairlessness makes us. We need clothing. It's not optional. Cultures also have attitudes toward body hair. What's attractive? What's acceptable? What should be removed? In many Western cultures, women are expected to remove body hair, shaven legs, armpits, sometimes arms. In other cultures, body hair is more accepted, or even valued. Men's attitudes vary too. Beards go in and out of fashion, chest hair, back hair, all subject to cultural preferences. These attitudes change over time, but they show that humans are very aware of their hair, and they care about it. We might not have much, but what we have matters. Sleep well, dream of ancestors adapting, of fur falling away, of smooth skin exposed to the African sun. Good night. Now let's compare humans to other hairless mammals, because we're not the only species that lost fur, but we might be the only one that lost it for the reasons we did. Elephants are mostly hairless. They have thick, wrinkled skin with scattered hairs. Why? Size. Elephants are huge. They generate enormous amounts of body heat just from their metabolism. Fur would trap this heat, cause overheating, so elephants lost their fur and rely on other cooling mechanisms. Large ears that radiate heat, mud baths, water. This is called gigantothermy. Using size itself as a temperature regulation strategy. Humans aren't elephants, we're not that big. We don't have their size-based cooling problems, so elephant hairlessness isn't a good model for human hairlessness. Rhinoceroses are similar, large, mostly hairless, thick-skinned. Same reason as elephants. Hippos are also mostly hairless, but they spend much of their time in water. The water helps with cooling, and fur would be less useful in an aquatic environment. Whales and dolphins are completely hairless, but they're fully aquatic. They evolved from terrestrial mammals but adapted to marine life. In water, fur is useless. It creates drag, reduces speed. So marine mammals lost it and rely on blubber for insulation. Again, not a good model for humans. Naked mole rats are hairless. These are small rodents that live underground in East Africa. They're social, living in colonies. They maintain stable burrow temperatures through communal behavior. And in their underground environment, fur isn't necessary. The temperature is constant. There's no sun exposure, no need for insulation, so they evolved hairlessness and actually benefit from it. Their bare skin is sensitive, helps them navigate tunnels, but humans don't live underground, so this isn't our story either. The point is, other hairless mammals lost their fur for specific, understandable reasons. Size, aquatic lifestyle, underground living. Humans are the odd ones. We're medium-sized, terrestrial, living in variable environments. We don't fit the typical hairless mammal profile, and that makes our hairlessness even more mysterious. Let's talk about sweating in more detail, because this is closely connected to hairlessness. Humans have two types of sweat glands, eccrine glands and apocrine glands. Eccrine glands are the cooling glands. We have 2 to 4 million of them. Distributed all over the body, they produce watery sweat, mostly water with small amounts of salt and other compounds. When this sweat evaporates, it cools the skin. This is evaporative cooling. Extremely effective. Humans are the sweatiest mammals on Earth. We can produce more than 1 liter of sweat per hour during intense exercise. This allows us to regulate body temperature during prolonged physical activity. We can run for hours without overheating. Most mammals can't do this. They rely on panting, or they avoid the heat of the day. But humans? We can run in the midday sun, chase prey until it collapses. This is our superpower, and it only works because we're hairless. If we had fur, the sweat would get trapped, couldn't evaporate, wouldn't cool us. Apocrine glands are different. They're concentrated in armpits and groin. They develop during puberty. They produce oily sweat, contains proteins and lipids. Bacteria on the skin break it down. This creates body odor. Why do we have these glands? Probably for chemical signaling, pheromones, communicating reproductive status, attracting mates. They don't contribute to cooling. They're purely social. And they're located where we kept hair, armpits, pubic regions. The hair helps trap and disperse the odor. So humans are unusual. We have this elaborate sweating system, millions of cooling glands, a few signaling glands, and hairlessness allows both systems to work. Cooling works because skin is exposed. Signaling works because hair is present in key areas. It's an elegant system, but it required losing most of our fur. Let's discuss the disadvantages of hairlessness. Because it's not all benefits. There are real costs. First, sun exposure. Without fur, our skin is directly exposed to UV radiation. This causes sunburn. Painful. Damaging. It causes skin cancer, melanoma, squamous cell carcinoma, basal cell carcinoma. Dark skin provides protection, but even dark-skinned people can get sun damage with enough exposure. Light-skinned people, especially those who migrated to sunny regions, are extremely vulnerable. Skin cancer is one of the most common cancers in humans, especially in populations living near the equator with lighter skin. Second, cold. Without fur, we're vulnerable to cold temperatures. Fur provides excellent insulation, traps air, keeps body heat close to the skin. Without it, we lose heat rapidly. Hypothermia is a real risk. This is why humans had to develop clothing and fire and shelters. We couldn't survive cold climates without cultural adaptations. Even in tropical environments, nights can be cold. Without fur, we get cold at night. Third, physical protection. Fur protects against abrasions, cuts, insect bites, thorns, sun. Without it, we're more vulnerable to injury. Our skin is soft, easily damaged. We bruise, we cut, we scratch. Fur would have provided a layer of protection, but we lost it. These are real costs, and evolution wouldn't eliminate fur unless the benefits outweighed them. So, whatever advantage hairlessness provided, cooling, parasite reduction, or something else, it must have been significant. Significant enough to justify the costs. Let's talk about hair loss conditions in modern humans. Because even though we're mostly hairless, we can lose the hair we have left. Male pattern baldness is the most common. Androgenetic alopecia. It affects about 50% of men by age 50. Hair on the scalp thins, recedes, eventually complete baldness on top of the head. Why does this happen? Genetics, hormones, age. The hair follicles become sensitive to dihydrotestosterone, DHT, a hormone derived from testosterone. DHT causes follicles to shrink, produce thinner, shorter hairs, eventually stop producing hair altogether. But here's the strange part. This is programmed. It's genetic. It happens predictably. Why would evolution create a system where men lose their head hair? Head hair is one of the few types of hair we kept. Why lose it? Several theories. 1. It's sexually selected. Women find bald men attractive or masculine, so the trait persists. But this seems unlikely. Baldness isn't universally attractive, and it's not unique to humans. Other primates don't go bald with age. 2. It's a side effect. The genes that cause baldness might be linked to other beneficial traits. Higher testosterone levels, greater muscle mass, dominance behaviors. So baldness persists not because it's beneficial, but because it's tied to things that are. 3. It's neutral. Baldness happens after reproductive age. Natural selection doesn't act strongly on traits that appear after you've had children. So male pattern baldness accumulates in the gene pool because there's no pressure to eliminate it. This third explanation is probably closest to the truth. Women can also experience hair loss, but it's less common and less severe. Female pattern hair loss. This is also hormone-related, often associated with menopause, decreased estrogen levels. Again, it happens after reproductive age, so there's little selective pressure against it. Other forms of hair loss exist. Alopecia areata, an autoimmune condition where the immune system attacks hair follicles. Telogen effluvium, temporary hair loss due to stress, illness, or hormonal changes. These conditions show how complex hair growth is. It's regulated by genes, hormones, immune function, stress levels. And when any part of the system malfunctions, hair can be affected. Now let's talk about body hair and sexual dimorphism. Because men and women have different patterns of body hair. Men typically have more body hair, thicker hair on the chest, back, arms, legs. They also develop facial hair, beards, mustaches. Women have less body hair, and what they have is finer, lighter. This difference emerges during puberty. It's driven by hormones, testosterone in men, estrogen in women. Why this dimorphism? Several possibilities. 1. Sexual selection. Women prefer men with more body hair. It signals masculinity, maturity, reproductive fitness, or men compete with each other. Beards might signal dominance, aggression. Status. 2. Thermoregulation differences. Men have more muscle mass, generate more heat. Maybe slightly more body hair helps with cooling somehow, but this seems unlikely. More hair would impede cooling, not help it. 3. It's a byproduct. Testosterone affects many traits: muscle mass, bone density, voice depth, and also hair growth. These traits are selected for, and body hair comes along as a side effect. This third explanation is probably correct. Body hair dimorphism isn't adaptive. It's just a consequence of hormonal differences that are adaptive. But cultures interpret it as meaningful. Masculinity, femininity, attractiveness. These interpretations aren't biological. They're cultural, but they're powerful. Let's discuss the future of human body hair. Will we continue to lose it, or keep what we have? Evolution is ongoing. Humans are still evolving, so it's possible that our hair patterns will change. But modern humans face different selective pressures than our ancestors. We have clothing, heating, air conditioning. We can control our environment, so the cooling advantage of hairlessness might be less important now, and the protection disadvantages might not be offset. This could lead to less selection for hairlessness. Maybe more body hair will become common again. Or maybe not. Sexual selection might maintain current patterns. If people find hairlessness attractive, it will persist. Another factor, modern medicine. Skin cancer is treatable. We have sunscreen. UV protection, so the costs of hairlessness are reduced. This might allow more variation. In the far future, if humans colonize other planets or adapt to radically different environments, body hair might change dramatically. Cold planets might favor more body hair, hot planets even less. But in the near term, thousands of years, human body hair will probably stay roughly the same. We're stuck with what evolution gave us. For better or worse, sleep well, dream of evolution, of ancestors losing fur, of the genetic changes that made us naked apes. Good night. The loss of human body hair remains one of evolution's most fascinating mysteries. We can propose theories, we can gather evidence, but we can't definitively explain why our ancestors shed their fur 2 million years ago. Was it cooling? Probably partly. Was it parasites? Maybe. Was it sexual selection? Possibly. Was it all of these combined? Likely, but we'll never know for certain. We can't go back in time, can't observe the pressures our ancestors faced, can't measure the benefits and costs in real time. All we can do is look at ourselves, at our hairless bodies, at the few patches of hair we kept, and recognize that we're strange, unique. Unlike any other primate, we're the naked apes, vulnerable but adaptable, exposed but innovative. We lost our fur, and in doing so, we gained something else. The ability to run long distances, to hunt in the heat, to survive in environments where other primates couldn't, and eventually to spread across the entire planet, to adapt to every climate, every environment, from tropical jungles to Arctic tundra, from deserts to rainforests. We did this without fur, with just our hairless bodies, our sweat, our ingenuity. And now we cover our nakedness with clothes. We build shelters. We create technologies to control our environment. But underneath it all, we're still those hairless apes, carrying the legacy of an evolutionary experiment that happened 2 million years ago. The mystery of why we lost our fur. We can't fully explain it, but we live with the consequences every day. When you look in the mirror, when you feel the sun on your bare skin, when you sweat on a hot day, you're experiencing the result of that ancient change, that strange adaptation that made us human. Sleep well, dream of smooth skin and ancient mysteries. And remember, you're a naked ape, and that's what makes you human. Good night.